A discussion on decision trees is best understood with an analogy of our daily lives. Think about how we are often put in situations where we make choices based on certain conditions, where one choice leads to a specific result or consequence. Hello everyone, my name is Bang and welcome to this fantastic video on the decision tree algorithm. In this video, we will delve into decision trees topics like what is decision tree, the advantages of decision tree. Moving forward, we will see applications of decision tree and some important terms used in decision tree. At the end of this video, we will implement hands-on using the decision tree algorithm. Just a quick info for you. Decision tree is after all an algorithm that is based on AI and machine learning. A professional who wants to switch careers with AI and ML by learning from their expert. Then try giving Simplilearn postgraduate program in AI and machine learning from Purdue University in collaboration with IBM. In this AI/ML course, learn in-demand skills such as machine learning, deep learning, NLP, computer vision, reinforcement learning, generative AI, prompt engineering, ChatGPT, and many more. The link in the description box should navigate to the home page where you can find a complete overview of the program being offered. So take action, upskill, and get ahead. So without any further ado, let's get started. So what is a decision tree? A decision tree employed in supervised learning is a tree-like structure designed to forecast the outcome of target variable. In supervised learning, which relies on labeled data containing known output variables, predictions are made through regression and classification algorithms. These algorithms serve as guide in training a model with a predetermined output variable. By grasping uncomplicated decision rules based on diverse data features, the model learns. Python's decision tree prove versatile, handling both classification and regression challenges, often finding application in assessing probabilities. So moving forward, let's see advantages of decision tree. Decision tree are simple to understand, interpret, and visualize. The second one is they can effectively handle both numerical and categorical data. The third one is they can determine the worst, best, and expected values for several scenarios. The last one is they perform well even if the actual model violates any assumptions. So moving forward, we will discuss some decision tree application. So the first one is a decision tree is used to determine whether an applicant is likely to default on a loan. The second one is it can be used to determine the odds of an individual developing a specific disease. The third one is it can help e-commerce companies in predicting whether a consumer is likely to purchase a specific product or not. The fourth one is decision tree can also be used to find customer churn rates. So moving forward, we will see some important terms used in decision trees. So the first one is entropy. Entropy is the measure of uncertainty or randomness in a dataset. Entropy handles how a decision tree splits the data. The second one is information gain. The information gain measure the decrease in entropy after the dataset is split. The third one is Gini index. The Gini index is used to determine the correct variable for splitting nodes. It measures how often a randomly chosen variable would be incorrectly identified. The fourth one is root node. The root node is always the top node of a decision tree. It represents the entire population or data sample, and it can be further divided into different data sets. The fifth one is decision node. Decision nodes are the subnodes that can be split into different subnodes. They contain at least two branches. The sixth one is leaf node. A leaf node in a decision tree carries the final result. So these nodes, which are also known as terminal nodes, cannot be split any further. So let's move forward to the demo part. So first we will rename this Jupyter notebook like decision tree, right? Okay. Okay. So first we will import some major libraries like NumPy, Pandas, Matplotlib, sklearn, Seaborn. So first we will import Pandas as PD, right? Okay. It is Pandas as PD. Then I will import NumPy as NP. Then I will import matplotlib.pyplot as PLT. Then we will import sklearn and then we will import matrix on them. So from sklearn import matrix, right? Then we will import cborn as SNS from sklearn dot datasets. Okay, I will import load iris. So I will import the iris dataset, the flower one. Then moving forward, we will import some model selection, sklearn dot model selection, import train test split, right? Then from sklearn import tree, decision tree. We will make decision tree like tree shape structure. Okay, so let me run this. Yes, everything is fine. Okay, it's still loading. Yeah, so everything is fine. So moving forward, we will import dataset, or you can say the load dataset. We will load dataset. Iris equals to load iris, right? Yes, it's working fine. Then data equals to pt dot data frame, and data equals to iris dot data. Okay, then comma columns equals to iris dot feature names. Okay, then I will run it. If I will check data dot head, what it will show. See, you can see the data set: sepal length, sepal width, petal length, petal width. Okay, yes, first give me, yes. So let's make species as a target variable. Okay, so first I will write here data species equals to iris dot target. Then I will write here target equals to np dot unique, then iris target, iris dot target. Okay, then I will write target and variable equals to np dot unique, then iris dot target names. Okay, then target dictionary equals to dictionary in zip file, then comma target n underscore n, right? Then moving forward, I will write data species equals to data species dot replace target dictionary, right? Let me run it. Okay, it's working fine. So we set target as a species. Okay, then now what we will do, we will make x and y column, okay, for the train and test split. So I will write here x equals to data dot drop columns, right, equals to species, then y equals to data again species, right, then names underscore features equals to x dot columns. We are assigning names features to x column, and here I will write target labels target labels equals to y dot unique. Okay. Okay. So here we will split the data set into train and the test. Okay. So x underscore train comma x underscore test comma y underscore train comma y underscore test equals to train test split x comma y comma test size equals to 0.3 comma random state equals to 93. So what does this test size 0.3 means? So test size 0.3 means we are splitting test and test data and the train data into 70% and the 30%, right? 70% means training data, the 30% is remaining is the testing data. Okay, so I will run it. Right. So here I will write from sklearn dot tree import decision tree classifier. Okay. Then here I will write DTC because I can't write decision tree classifier again and again. Decision tree classifier max depth equals to 3 comma random state equals to 93. Okay, DTC dot fit. Okay, 93. No, it's comma random state is 93 equals to 93, right? Then DTC dot fit x train comma y train. Okay. Then PLT dot figure, then figure size equals to 30 comma 10 comma face color will be face color equals to B. Then I will write tree equals to tree dot plot underscore tree, then DTC decision tree classifier comma features names features name comma class names equals to target labels comma rounded equals to true. Then I will write comma filled with true values comma font size will be 14. Okay. Yes. So now I will write here PLT dot show. Okay. Then y prediction equals to DTC dot predict x test. Okay, decision tree classifier is not defined. Maybe some spelling mistake is there. Okay, let me check now. Okay, feature names is not defined. Okay, where is feature names? Okay, features name. Why is that features name? Okay, this is names underscore features. Right. So what I will do, I will write first full code. Then I will show you the both graphs. So I will write here confusion underscore matrix equals to matrix dot confusion matrix, right? Then y test comma y prediction. Okay, then matrix equals to pd dot data frame, then confusion matrix. Okay, we will create one confusion matrix graph heat map. So I will write sns dot heat map matrix comma not equals to true comma fmt equals to g comma axis equals to axis comma cmap sitemap equals to magma, then axis dot set title is confusion matrix. Okay, then we will set the x label, x tick label, y label, y tick label. Okay, then I will write here axis dot set x label predicted value comma font size equals to 10, then axis dot set x ticks labels okay plus target labels, then axis dot set y tick labels, then list will become, then target labels will show, then I need one rotation of 0 and equals to 0, then I will write plt dot show. Okay, so let me run it. So as you can see, the decision tree is here, but there is confusion with confusion matrix. Okay, first I will restart and clear all outputs. I will do, and let me run it again. Okay, so there is some confusion. Okay, so issue is confusion matrix is not defined. Okay, it's matrix, now it will come. Yes, so as you can see, confusion matrix is here and the decision tree. This is how you can make the decision tree. We already discussed this word Guinea, right? The samples, values. So these petal length, petal width are from the data set. Got it? And this is confusion matrix of particular data set. You can see we have 3 categories: Setosa, Versicolor and Virginica. Okay, so we have come to end of this video. If you have any doubt, please ask in the comment section below. Our team of experts will help you as soon as possible. Thank you and keep learning with Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.